To determine if the existing switchgear can handle the additional load, firstly calculate the total load. The information states 159 kilowatts times 2 machines equals 318 kilowatts. Secondly, convert kilowatts to kilovolt amps. The formula is kilovolt amps equals kilowatts divided by the power factor. Assuming a power factor of 0.8, 318 kilowatts divided by 0.8 equals 397.5 kilovolt amps. Confirm that the existing switchgear has sufficient capacity to handle this additional 397.5 kilovolt amps load. Since the machines require 480 volts and the existing switchgear is 575 volts, transformers are required to step down the voltage. Choose transformers with a kilovolt ampere rating that is suitable for the load. 225 kilovolt amps is sufficient. Install two 200 amps disconnects to protect the transformers from short circuits and overloads. Connect the disconnects to the existing switchgear. Run cables from the disconnects to the transformers. To size the cables from the transformers to the machines, determine the current demand of the machines, which is 192 amps maximum. Use the following formula to calculate the cable size. Cable size in American wire gauge equals log of current divided by 40 times voltage drop percentage times conductor temperature factor divided by log of 2. For example, if you want a voltage drop of 2% and a conductor temperature factor of 0.8, the cable size would be log of 192 divided by 40 times 0.2 times 0.8 divided by log of 2 equals 3/0 American wire gauge. Verify that the transformers have overload protection devices to prevent damage during overloads. Ensure that the cables are properly sized and installed according to code requirements. Perform a power factor correction study if the power factor is not at the desired level. Consult with a qualified electrician or engineer for a detailed design and installation plan.